So in this video, we're going to be talking about the science behind leavening baked goods. So what do I mean by leavening? To leaven a baked good is to make that dough or batter rise by introducing a gas. And a leavening agent is the ingredient that will aid in introducing that gas to leaven the dough. So before I get into the definitions involved in leavening and the process of leavening a dough or batter, I want to talk about gases. So we talked about states of matter a long time ago at the beginning of the semester, and we were talking about states of matter and their particles. I want to refresh ourselves on what's going on with the particles within a gas. So when I'm envisioning these particles in a gas, I'm envisioning particles that are really spread far apart. There's a lot of distance between those particles. And those particles are moving constantly in straight lines at very high speeds, about 1,000 miles per hour. And they're colliding with each other, and they're colliding with container walls. And their speeds are dependent on temperature, because temperature is a measure of that average speed. So as the temperature is cranked up, say in an oven, those particles are starting to collide with each other more often, and they're getting faster and faster. So when we talk about gases within in the relation to temperature, there's a really important gas law that's going to relate to leavening of dough, and that is a gas law that's called Charles' law. And this law looks at the relationship between temperature and volume of a gas. And a great way to think about this is if you've ever seen a hot air balloon like I have pictured here. So in a hot air balloon, there's a finite amount of gas within that balloon. And the hot air balloon engineer, driver, I'm not sure what they're called, but what they do is they blast really hot air into, they blast a furnace basically into that balloon to heat up that air and to get those particles moving. And as those particles start moving faster and faster, that volume starts to increase because the particles are starting to punch against the balloon walls and are expanding it out. So we see that as temperature increases within a gas, the volume will increase if that pressure remains constant. And so this means that temperature and volume are directly proportional. And this is really important because this is directly what is involved in leavening of dough. So when you have that gas introduced into the baked good and you put that baked good into the oven, that gas starts to heat up. The particles are colliding more often against that dough, and it's expanding. Those little bubbles become bigger bubbles, and they create larger pockets within the dough or batter to make it rise. So there's a number of ways in which we can leaven dough or batter or other products, and I'm going to go through those four methods with you. Those methods of leavening products are mechanical, steam, biological, and chemical. So, the first process, the first method is called mechanical leavening, and this is where you physically introduce air into the product. A couple methods of, a couple examples of this that you may be familiar with would be whipping egg whites or creaming sugar with butter. When you're whipping egg whites, you're moving that whisk really fast, and you're bringing in air and creating extra pockets of air. When you're creaming sugar with butter at the beginning of making, say, cookies, what's happening is you're dragging those granules of sugar within the butter, and you're breaking up the butter, and you're creating little pockets of air that will then expand when it's baked. Steam leavening takes water that's already in the food and converts it into steam that can then expand when it's baked. A couple examples, puff pastry is probably the most common example of steam leavening, and then also popovers, which is not something I was necessarily familiar with before, but it is an experiment that we were going to do in person in lab in the second half of class. But popovers are a baked good that uses uses the steam within the product to make a very, it really pops up and over the edge of the muffin tin, which is why they're called popovers. Check out a recipe sometime. The next method of leavening is called biological leavening, and this uses what we learned in the fermentation lesson to introduce CO2 gas. So yeast is used to ferment, and it digests sugar and it produces that CO2 gas. Now, in order for yeast to work as a leavening agent, yeast is a living substance, so it needs specific conditions in order for it to grow and produce that CO2 gas. So first of all, you need moisture. It can't happen just dry, and so that's why yeast comes as little dry granules. As soon as that moisture is introduced, it will start to ferment. Some sort of fuel. So the most common fuel that you'll see in recipes that use yeast is just a table sugar or sucrose. You can use things like honey or maple syrup as well. And then you need an optimal temperature. And in the next lesson, we're going to be exploring what is that optimal temperature for yeast to grow. And we're also going to be looking at what happens when you vary how much of that sugar you provide to the yeast. So when you're baking with yeast, there's a few things you need to keep in consideration. The first is that this is going to be a time-consuming process for you. Yeast baking takes a lot of time. Yeast will need multiple rises, lots of time for it to ferment. So you need to have multiple rises. You need to wait for that yeast to start growing. This is a project that is not going to be a quick bake, which is why yeast bread is not called quick bread. We'll talk about how, if you want to bake quickly, maybe a better choice for a leavening agent. Yeast produces quite a bit of gas, so this is a good leavening agent for something that needs a lot of rising to occur. So a lot of breads use yeast because you'll see big pockets of air within them. And then also, to hold in all of that gas, you need a pretty strong dough, so that has lots of gluten content. So we learned that kneading will increase that gluten content. So gluten and yeast go hand in hand. A really strong dough will allow for more leavening, and that yeast, because it produces more gas, will fill up quite a bit of space. The last type of leavening agent, and this is the one where if you want a quick bread, you're going to see these ingredients involved. So chemical leavening, in chemical leavening you have an acid that reacts with a bicarbonate compound to produce CO2 gas. So this is one of those reactions that we saw in our acid-base discussion, where you have an acid and a bicarbonate compound, which is a base. And bicarbonate compounds, when they react with an acid, they have a special process that occurs in that neutralization reaction where you actually get it breaking down further into that to produce that CO2 gas. So there are two types of chemical leaveners. The first is baking soda. Baking soda is pure sodium bicarbonate, NaHCO3. When you're using baking soda, you need an acidic ingredient in the food to react with the baking soda. Baking powder, on the other hand, is a homogeneous mixture that has multiple components. Typically, it will have baking soda as one of the ingredients, along with 1, 2, maybe 3 other acids. They're all in powder form, so they're not going to react with each other in that powder form, but as soon as you add some liquid, they will start reacting. When you're using baking soda, as I said, you need to have an acidic ingredient. Now, there's lots of acidic ingredients that we learned in our acid and bases lesson, that most foods that we eat are acidic. However, some of the most popular to use within a baking recipe are yogurt, vinegar, buttermilk, and believe it or not, brown sugar is an acidic ingredient. So when you're baking with chemical leaveners, the time is relatively quick. This is why breads that use baking soda or baking powder are known as quick breads when you look them up in some older recipe books. They don't produce quite as much gas as yeast, and so this is actually goes hand in hand with the fact that you don't need as much gluten content to hold in all that gas because there's not quite as much gas. So typically we're going to see chemical leaveners used in more sweet baked goods because those tend to have a more tender texture, and so we don't want as much gluten content. So with our more sweet baked goods, we tend to use a chemical leavener with a flour that has a lower protein content. When you're looking at things like breads and more savory baked goods, you're going to see yeast used with a higher gluten flour.